Thank you. Yes, so I'm Björn Löfroth from Irori, where we typically care about making systems integration easy. But for this talk, I guess a more correct phrasing would be to make it less hard. And the talk is called When GitOps Goes Wrong and Some Other Challenges for Strimzi Platform Teams. And then quickly about me, I've been working in Strimzi platform teams since about 2019 and been doing systems integration since 2013. And I'm based in Stockholm. And I always enjoy a good troubleshooting session, which came in handy for the content presented here in this talk. And my first idea for this presentation was to do some kind of a ghost story theme, but then I realized I don't have the acting skills required for that. And it would also detract away from the very important lessons learned. But we'll still start with some disclaimers here that some Strimzi Kafka clusters were harmed in the making of this presentation. And the bugs and issues that were the root causes have probably long since been patched, at least in my knowledge. So we will instead focus on the more general lessons learned. So first, we're going to focus on GitOps. And what do we mean when we say GitOps? Well, it's short for Git operations. It's a way of doing declarative configuration and infrastructure as code. And I was looking up if there's any like more formal definition, and the closest I got was this CNCF GitOps working group, which then lists 4 properties for what is GitOps. It has to be declarative, has to be versioned and immutable, it has to be pulled automatically, and continuously reconciled. And I put a little asterisk around pulled automatically here because that's not typically how we have used it in my teams, but there, in my opinion, there's no big difference to pushing this configuration automatically. But in this definition, we probably would instead just be sparkling declarative configuration. Nonetheless, if we look at an example here, how can it look like? You probably have similar setups in your teams when you deal with Strimzi, but you can have a Git repository with a Helm chart and some values file, or maybe multiple values file for different environments. And in turn, this declarative configuration gets deployed inside a Kubernetes cluster, and you get your Strimzi resources, such as the Kafka cluster. And then, of course, you have your Strimzi controller that reacts to this definition and creates a number of other resources, such as the pod set, which in turn creates the pods. And you have other things like the persistent volume claim. So this is the kind of reconciliation and automation that happens after you put your declarative configuration in place. So everything that happens in the Kubernetes cluster is just one big reacts to video of different things interacting with each other. So if we move on to how does GitOps contrast other ways of doing operations and configuration? Well, GitOps is declarative. And what do I mean by that? Basically, what you say is, I want to achieve this desired state. And some examples of that are Kubernetes or Terraform typically. And then you have this other category, what I would like to call script ops, which is more imperative in the same way as your typical programming language. Run these operations in this sequence. And typically you would ignore the current state, although you can do some checking and perhaps making sure your operations are idempotent, that you can run them again. Typically the tools used would be Bash or to some extent Ansible, or maybe that's more a bit gray area. And then on the other right-hand side, some more manual strategy, what I would say click ops. Basically, you click a button, you enter this text, you click next, and this is something you typically do in your cloud provider web portal, which has its uses. But if we instead focus on why would you like to do GitOps? Well, here are some reasons at least. You would get a single source of truth of the configuration and setup in your environments. You're using a familiar and trusted review and approval flow that developers are used to. and you get the ability to do disaster recovery in some sense, at least of the infrastructure, maybe not the data per se, just by using GitOps, but you can recreate it from your definition in Git. You also get reproducible environments. Say that you have an issue in a certain environment, for example, production. You could then spin up an identically configured cluster, for example, stage, and then be able to reproduce some issue or bug in that. You get auditable changes, see who did what when to the configuration, and it allows you to enable some kind of self-service flow where users can open pull requests to suggest some changes or Kafka topics or what have you. But those were the benefits. So now this is where I switch to the scary voice and we go through a nightmare scenario. What can happen when you have this kind of automation and everything with Strimzi and Kubernetes and these layers? So it all started a rainy evening with an innocent syntax issue in the Helm values file. And because of a very specific bug in a very specific Helm version that we used, when this was applied in the Kubernetes cluster, we got a set of basically an empty output, but no error message. So what happens then? Well, basically all the Kafka topic custom resources are removed, and then the automation kicks in. Strimzi, of course, deletes all the topics as advertised or as the functionality is, and Kafka deletes all the data. And this leads to, of course, panic in the platform team, some analysis, and then some disaster recovery and mitigation. And I won't go into the details of the recovery, but in this, we're pretty early on in our journey with the Strimzi and Kafka, so we did not have any kind of disaster recovery cluster, which we ended up adding later. In this case, we only had disk backups, which we knew were not ideal, but we turned out we could use them here. Basically, we were lucky because most consumers were live and they were tailing, like consuming the end of their topics. So there was no big issue there. And for some other cases, luckily, we could do some manual recovery. But this is very, very much not an ideal scenario and the nightmare as the platform team. But at the end of the day, we lived to tell the tale and we learned some very important lessons, which we will go into. So we will consider both specific ones and general ones. So the specific, most important one is to disallow topic deletion in your production cluster. You can either do it on the Kafka level, on the cluster configuration, or you could in theory do it on some kind of Kubernetes level where you disallow the delete operation for the Strimzi custom resources, the Kafka topic custom resource. For example, if you have, you might want to at some stage delete some old topics, but that should be a rare case and you should be protected against it in the normal case. And the general version of this is, of course, to be conservative about any permissions for destructive or high impact operations. And then, so this is a very specific scenario, but you should probably use time-tested tool versions. So had we used a more mature Helm version that had been out longer, we probably would have avoided this issue because it's likely someone else would have run into it first. And these backups for Kafka are not so valuable. Typically, we did them at midnight. So, the interesting stuff that people might not have consumed are usually at the tail end of your topic. So the disk backups from a couple of hours ago are not very interesting. Depends, of course. You can add compacted topics and that stuff. So they can be valuable, but we later moved on to other setups with mirrored clusters. And in general, to understand your automation tools and the risks associated with them. And we will get back to this risk analysis a bit later. For now, we will move on to another area, with certificates. And Strimzi, of course, as many of you probably know, have a lot of interesting and useful certificate features. You can generate the client certificates that the clients can use to authenticate. You can have them automatically renewed. You can set up maintenance windows. You could generate your CA certificates, or you can import some certificates. But what we're going to run into here, and now I actually have a look in the documentation, there's actually a disclaimer. I'm not sure if it was there back when we had this issue, but it's very valuable to have it put there. It says then a bit about how you allow the certificate renewal, but it says, nevertheless, unexpected operational problems or disruptions may prevent the renewal process. And this is what we will get into in this scenario. So here it all started with a cluster CA cert renewal that was, it was up for renewal and the whole process got triggered. It was scheduled to a maintenance window at midnight. It's not really important for what happened, but still, that was a known feature. It failed for an unknown reason that we were not able to reproduce in lower environments. But we haven't seen it since, so I think it's fixed, or we have changed some configuration in the cluster that makes it not appear again. And unfortunately, we did not have any specific monitoring for this failure. So time passed and the renewal kept failing. And of course, then I guess this is a tale as old as time when you have certificates. Someday in some scenario, you will fail to renew them properly, which happened here. The old certificate expired, the clients cannot connect, and then the intense troubleshooting starts. Fortunately, in this case, the fix was much easier. We could force renewed certificates. I think we maybe restarted some pods as well, but it was rather quick to actually fix it. But then we had to redistribute the new certificates, I think. So some lessons learned here. Some specific ones is, of course, to monitor your certificate expiry. I think we installed what's called cert exporter as an operator to monitor certificates in secrets. But I also recommend maybe a manual way. Just keep a schedule on when different certificates are up for renewal. And just also for this monitoring, don't just monitor the secret content. You might also want to monitor the actual certificates served by the Kafka brokers, because we had an issue where that was not updated. And regards to this first point, you should probably schedule some ops activities for the certificate renewal. So if you're using some process where you register changes and assign personnel, you should probably do that for the important certificate changes. And then a more general lesson or principle that we were actually using, but I think is still valuable, is to have a more frequent certificate renewal in your lower environment, such as dev and test. Because then this way your clients, they might have different ways and processes of renewing their certificates, and they get to then exercise them more often in lower environments. So if there was a case with some issue, either in their process or in your renewal, you're more likely to detect it in the lower environment. And then the last general lesson here is to invert your way of thinking. Invert, always invert. And what do I mean by that? Well, that's based on an anecdote by this guy. His name is Charles Munger. He was an investor and businessman, and I think he has probably a lot of anecdotes and advice out there on YouTube for those who want to look it up. But this specific one is about when he worked as a weather forecaster for the US Air Corps. And instead of then posing the more normal question, like, how can I make good weather forecasts? He instead inverted the approach here. How could I kill these pilots, or what could kill these pilots? It's a bit brutal way of thinking, but it's about, of course, avoiding it, right? But in order to do it, you need to get into that line of thinking. So he concluded that there are only two main ways that the pilots could get killed because of bad weather forecasting. He could get them into icing that the plane can't handle, or they could run out of gas before they could land at an available airport. So you might ask yourself, what does this have to do with Kafka? Well, I suggest that we all invert our way of thinking about Kafka as well. Of course, we want to keep it up, but what if you just think about how can we take Kafka offline, or at least effectively offline? And you can probably brainstorm even more areas, but let's look at these ones that I thought about. So of course, based on the experience here, the authentication issue, cert renewal failure, is a big one. If no client can connect because of expired certificates, that makes a cluster effectively offline. Configuration failure, when we happen to, because of some tooling, in this case, remove all the topics, that takes the cluster effectively offline, at least for the purposes you want, right? And then you could easily imagine some network access issue, like a firewall misconfiguration or some new security policy being applied that blocks out all the network traffic. And the more probably easy one to imagine is, of course, the disks becoming full. But probably there are a lot of alerts and everything already prepared for that, but it's an important case nonetheless. And perhaps you could reach some kind of memory or pod limit in Kubernetes, which would then out of memory kill your pods, so they will keep restarting, which is maybe not a hard offline, but it's pretty bad still. So these are the ones I could brainstorm up, but you could probably do specific ones in your scenarios. And then so that's step one. Then step two is then what you want to do about it. You want to at the very least detect when it happens, and ideally, of course, you want to prevent it and mitigate it. So I can say that we got a bit paranoid after the Helm issue, so we put in both 1 and 2 extra saves for that specific scenario in both our pipeline and, of course, the configuration mentioned here. But yeah, you should look at your own setup and try to take some steps that make sense for you. So let's move on to another, which is not strictly about the uptime of the system, but it still can be a challenge for the platform teams. So it's about component life cycles then. So what if we look at the Strimzi habitat? Where does the operator and the Kafka cluster live? Well, they live in a Kubernetes cluster. They have the ingress control. Well, there is probably an ingress controller, not necessarily used by Strimzi, but the other applications in Kubernetes might use it. You have your CRD definitions. You have your monitoring stack. You might have Kafka Connect and some other operators, and of course your microservices or services. But they all have dependencies, like as we I think it was Thomas discussed a bit in the phased upgrades talk, the challenges with and the risks and the ways of mitigating the risks when upgrading Strimzi and the CRDs. So it highlights the dependencies that can exist with both the API version of the CRDs and Kubernetes, and also the Strimzi version. And then you have the other stuff. You might have a cloud provider that only has support for certain Kubernetes versions, and they might have support for some storage options and not others. So there's a lot to manage here with these dependencies. You might have other operators as well. So how do you approach all of this? Well, yeah, at the end of the day, you probably have to upgrade and test, but there might be some different approaches for that to get into. So we have mainly considered 4 different approaches. The most simple one or naive one is simply to upgrade piece by piece each component. But as we just saw, there are dependencies, so you might need to upgrade at least 2 or 3 pieces together, right? But if you still take this kind of minimalist approach, upgrade as few as the dependencies require, it can still be pretty time consuming. As you see, I think I listed 9. I think it was also mentioned previously to use canary clusters to test out different things, which is probably a good combination with an automated test suites. And if we move a little bit to the right here, to the more big bang approach, you could upgrade all of your components at once. And that would, of course, be high risk, and you wouldn't know which, if you encounter a failure, which component caused that. But on the other hand, you could save some time to do if what is it, like an expensive performance test suite that you only have to run once, or you have some manual tests that you only have to run once. But still, it's a lot of complexity and a lot of risk, and if anything goes wrong, you might need to do some rollback, and then you would be in some kind of uncharted rollback territory. So I think we have gravitated more to some kind of medium bang approach as a compromise, where we try to select groups of pieces that have to go together, or we just group them to get an acceptable amount of risk in one go. And then we do some rigorous testing once in a while, performance testing, for example. And then in case of a rollback, you have less complexity, but still complexity, right? But then if you move on all the way to the right here, we have another strategy that we've employed to do a blue-green failover. And this is where we have a mirror cluster where we mirror the data with MirrorMaker 2. And we do a failover. And in this setup, I think it's DNS-based failover to that cluster. And this could be useful when you have a lot of big changes to components that are either hard to upgrade in place or time consuming to upgrade in place. So the benefit here is that you can do some smoke testing before you actually do the failover. And if something goes wrong, you could do then a rollback to the exact known working cluster. Of course, you have to do some then manual data recovery, perhaps. But still, you have a known working cluster to use if you need to. And some more lessons learned or advices here is, of course, that you want to stay on reasonably recent versions, because they are the ones to be likely to be security patched in case of some vulnerability or anything. Log4Shell, if you remember. And so what you don't want to be is to be looking at that dependency graph when you have some time pressure to say, okay, I need to bump the minor or major version of, I don't know, the ingress controller, a number of steps. And then I also have these dependencies that I have to resolve. So if you have reasonably recent versions running, it's probably easy to apply individual security patches. And then, of course, you should test and plan for rollbacks. It's tricky, but you should at least consider the scenario. And canary testing can be used in different amounts, but basically, when you see new features in the pipeline for the components you have, try to bring them out in some smaller cluster to poke around to see, okay, how does it affect like the upgrade to that new feature, if it's, I don't know, CSI storage or something else. Try to do that in a smaller environment and see, like, probably when you read about it in a change log, you don't really know how it's going to affect you. So you need to actually do some testing and validate. And then you could try to build a lot of automated end-to-end smoke tests. And that's, of course, a time investment, but it might pay off if you're maintaining this platform and this cluster. So which might change the calculus for when it makes sense to do these individual piece-by-piece component upgrades, or when you then prefer to group them together more and more. So I think this was mostly it. So we're just wrapping up. Some final advice then, I guess, constant vigilance. Well, at least these lessons here have made me a little bit more paranoid and try to analyze the risk more carefully. And then I would advise you to look at it through this inverted lens, where you try to figure out, basically do a risk analysis. What are the important scenarios you want to prevent? And then I guess just a general word of good luck, I think. is appropriate to you all that manage Strimzi Kafka clusters, which generally work very well, I should add.
Thank you very much. That was a really interesting session. Lots of people in the chat sharing that they had hit some similar problems. So yeah, definitely be useful for those who are just starting out or who haven't hit these yet to prepare. There was some questions in the chat around how you prevent topics being deleted, but I think that has been answered in the chat now. So that people have linked to the right places in the Kafka docs, but we had a Q&A question, which was, how do you back up the content of your topics? I heard mirroring. Can you elaborate more about your setup?
Well, so the current setup we have in one organization is we have an identical failover Kafka cluster. We use MirrorMaker 2 to mirror both the topics and the offsets, of course. And then we have a failover mechanism, which is not as automatic as we would like, but it's semi-automatic, where we basically we have a DNS entry for the Bootstrap server, which we can then fail over to the other cluster. But then typically you would have, well, you could have then a little bit of data corruption during that period where people, if we do it, so when we did it as a controlled failover, we would then block access in the old cluster for a certain amount of time. And then we made sure that, and then we would allow access so we had the different like ability to tweak temporarily the topic accesses in the different clusters. So we've turned them off in the old cluster, turn them on in the new cluster, do some smoke tests, and then we would switch the DNS and allow people to use the new cluster. And they would need to probably, I think we determined they need to restart all of their client applications for the DNS change to take effect. You could probably imagine a more complex setup with some kind of load balancer there in between. We haven't got to that stage yet, but yeah, you could probably expand on that approach as well. So that would cover both this blue-green cluster approach when you do upgrades, but also you could use it for failover then.
Cool. Thank you very much. I don't see any other ones. I said there's a few people discussing the topic deletion. I don't know if you want to say anything about the pros and cons of doing it in Kafka directly on the server or doing it in RBAC and Kubernetes, whether there's a preferred approach from your point of view.
I think so. If you want to lock it down completely, which you might if you got paranoid here, you block it at the cluster level, and then you just turn it on for the specific cases when you need to delete some old topics that are deprecated or something like that. But we considered briefly an approach where we would have like manual admins that have access to delete topics at any time. But we would have a CI user that would then have only certain Kubernetes permissions, so it would not be allowed to use the delete on the Kafka topic resource. So I think that's a workable approach, which gives you more like permanent flexibility. But if you want to be really strict, I say default should be to block it at the cluster level.
Cool, thanks.